assignments that you haven't gotten done yet, you need to get them turned in first thing Monday. I'll say first thing Monday because, well, we've got multiple kids out for weightlifting and other things. So get them in first thing Monday because you should have had more than enough time at this point to get them done, especially with last week being a 5-day weekend. So go on and get those done because, again, multiple assignments. The assignments on a whole don't generate a whole lot of points. They're about 30 to 40% of the overall grade, but that's still a huge chunk of your overall grade. It is possible to pass this class and not turn a single assignment in, but that would mean you'd have to hit 100% on every single test, and you're looking at like a 60 to 65. So the homeworks do help, and the more zeros you get for those, the worse it gets. So, and staying on top of it does help, because that way you don't have to do 10 assignments plus all at once. Now, before we get started with this last part of law of sine, or dealing with law of sines and cosines, are there any questions on the homework from the last few days? Now, the last law that we're looking at is law of cosines. We don't look at law of tangents because realistically, anything that we can do with law of tangents can actually be done with law of cosine. Law of tangents really doesn't add a whole lot to it, and it also employs a lot of systems of equations, which make it a little more complicated. Now, law of cosines is used in two main cases. One of them is that if we have three side lengths, side, 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 or side, angle, side. So these are the two main setups that we're going to end up using law of cosines for. If we have all three sides, or if we have side, angle, side. And for the side, angle, side, A, B, C, little a, little b, c. So if we were given, say, A is 78 and then 9 and 14, we can't use law of sines for this. Because if we tried to set it up, because we could say 9 over sine of c, because we don't know what c is. We could say 14 over sine of b is equal to, well, we do have sine of 78, but it's over a. And in any of the two that we pick out of these three, we still have two things missing. Because if I pick the first two, well, they're both missing an angle. I can't use it because I'd have to solve for two things. If I pick the second two, well, one's missing an angle, one's missing a side. Since we have something missing from all three, we can't use law of sines to actually solve a triangle like this here. And this is where law of cosines comes in. So if we're solving for a missing side length, we're going to say that a squared is equal to b squared plus c squared minus 2bc cosine of a. Or that b squared is equal to a squared plus b squared minus 2ab cosine of, sorry, because our b squared, kind of thinking right at the same time, b squared is equal to a squared plus c squared minus 2ac cosine of b. And c squared is a squared plus b squared minus 2ab cosine of c. And the one way that I found easiest to kind of remember these equations is if we notice that the side length that is by itself, let's get a highlighter. Here, for the top one, it's a. In the entire equation, the only other spot that a shows up is as an angle. A squared is equal to b squared plus c squared minus 2bc cosine of angle A. A is on the outside, all the other side lengths inside are b and c, the others. And it's true for all three. B squared is equal to a squared plus c squared minus 2ac cosine of b. And we can use these to find a missing side length. So if we look at this first one here, solve the triangle, round your answers to the nearest tenth. Now we can't use law of sines. The law of sines really requires us to have a side and an angle opposite, and then another side or angle. And if we look at this here, well, 14, we have it, but we don't have the angle opposite. We do have the angle of 34, but we don't have the side opposite it. And our other side, 11, we have it, but we don't have the angle opposite. So this here is going to be law of cosines. And this is actually somewhat helpful on the ACT knowing this, because there is at least one problem that will revolve around law of sines and law of cosines. And I scoured through 6 of the practice ACTs, well, former ACTs, and only found about 4. 5 or 4 that I looked through, only found like 4 of them, and most of them didn't even require solving. It's set up. Can we set it up? So most of the time we look at this here, they'll give us answers with law of sines with the setup and law of cosines. Well, we don't have a side and angle opposite, so the ones with law of sines are gone. Now we look at law of cosines. And here, we want to solve angle B, or side length B first. So we're going to say that B squared is equal to A squared plus C squared minus 2AC cosine of B. This is the equation that we use. Now I don't know what the length of B is, so we'll leave it as B squared. Now the other 2 side lengths are what? Which one's A? Could I put 14? Yeah, because I mean, outside the A squared plus E squared, 11 squared plus 14 squared is the same as 14 squared plus 11 squared. That doesn't matter. Yeah, AC inside being multiplied, 11 and 14 is not going to make a difference. We just need to know that those 2 are going to be our other 2. So 11 squared plus 14 squared minus 2 times 11 times 14 cosine of 34, because the angle opposite side length B. So the angle that goes inside of cosine is always going to be the angle opposite the side we're solving. And there's a good chance on the ACT that's your answer. It's not going to ask you to go any further, because most of all the ones that I've seen so far, it's not asking you to solve for B. It's just, hey, which of the following equations is correct? Now, some of them might take it one step further, because here we have B squared. We're solving for B squared. Well, we really don't care what B squared is. We want the value of B to the first. So to get rid of the square with B squared, we square root it, which means we have to square root the other side. And it's good to do it in this way here, instead of calculating what 11 squared plus 14 squared minus 2 times 11 times 14 times cosine of 34, and seeing what that is and then taking the square root. It's a little bit better to do it all at once. So on the calculator, we can go second square root okay, let me try that again. Square root 11 squared plus 14 squared minus 2 times 11 times 14 cosine of, what was the angle? 34. And type the whole thing in and hit enter, and we get 7.852. Well, if we're going to the nearest tenth, we would round up to 7.9. So B is equal to 7.9. Any questions on this here? Okay, so we found one part of it, but we still need the other two angles. Now, before we get into that, I want to finish the thought I had a second ago. Because I said we didn't want to type this in first. 11 squared plus 14 squared minus 2 times 11 times 14 cosine of 34 in, and then take the square root of it. And the reason I say that is mainly dealing with cosine of 34. How many times have we typed in cosine, sine, or tangent of an angle and got a nice number? Very few, because we've got 1/2 and 1. 1/2, 1, and 0 are really the only three that are nice. More than likely, that's going to be an ugly decimal, yes? Which multiplied with 2, 11, and 14 and then subtracted from their squares is going to be an ugly decimal that we can't actually get the whole number. So if I'm going to get an ugly decimal that I can't actually get a whole number, I'm going to have to approximate and then take the square root and approximate. Might as well just type the whole thing in and approximate once. And it makes it easier to work with. So that's the reason I say we're better off just typing the whole thing in all at once than trying to do it in parts. Any questions on this here? Okay. Well, go to that right in the highlighter. Now we do need to find the angles. One of the ways we can go about finding the angles is based off law of sines, going back and using it. Law of sines works very well. The only issue is that dealing with sine inverse, for us to be able to use the function, its angles really have to be between negative 90 degrees and 90 degrees for it to work. So the inverse of sine is a little tricky, like we saw yesterday or 2 days ago, with the fact that sine of 60 degrees and sine of 120 give us the exact same value. But the inverse is only going to tell us that it's 60, not 120. So it does have some issues there. Now, that being said, we can use cosines inverse just fine, because the cosine inverse function is restricted for angles between 0 and 180. All the sum of the interior angles of a triangle is. So there's no way we would get outside of that range. So it works a little bit better. Do we want to solve for angle A or C first? A. Now, so A squared is equal to, you don't have to write this down. I want to show you this so that you can kind of see where this formula comes from that we're going to get to and essentially use from here on out. Really, we want to solve for angle A. Well, doing this here, well, all of the other three equations are essentially the same. It's just changing the value of a number or one of the spots. So what I want to do is get A by itself. So I'm going to subtract B squared and C squared from both sides. Because B squared minus B squared is 0. C squared minus C squared is 0. Telling us that A squared minus B squared minus C squared is equal to negative 2BC cosine of A. Because I'm just trying to get the angle by itself. At this point here, I can divide both sides by negative 2BC. Because again, we're just trying to get A by itself. And what that'll tell us is that cosine of A is equal to, so in the denominator we have our 2BC. I'm taking that negative and multiplying it through the top, which would make the A squared negative. The b squared is already negative, and a negative times a negative is a positive. Same is true for c squared. So we're getting closer to it. And the last step in getting a by itself is while taking the inverse, which really tells me that angle A is equal to cosine inverse of b squared plus c squared minus a squared over 2bc. And that's for A, yes? Now, as I mentioned earlier, really, whenever we're having the number or variable that's by itself, so here, first one was a squared, it only shows up once, right? And here, this one here, it only showed up in this spot here, yes? So if I wanted to say the equation for B, angle B would be cosine inverse of, well, what did I switch? I switched angle A for angle, so I'm going to switch side length A for, so that means this is going to be a squared plus minus over 2 AC. And we could say the exact same thing for angle C, because B is cosine inverse of a squared plus c squared minus b squared over 2ac. And C would be cosine inverse of a squared plus b squared minus c squared over 2ab. Questions on this here? And really, we could have gone and solved each one of these equations from this here, plugged in the values of a, b, and c, solved them, moved them over, and did the steps individually. But utilizing this equation is actually quite nice, because a is equal to cosine inverse of b squared plus c squared minus a squared over 2bc. So angle A in this case is cosine inverse of, what's the value of B for this problem? So we have 7.9 squared plus C is 14. 14 squared minus 11 squared over 2 times 7.9 times 14. Questions on this here so far? Yeah. Now, I did all the steps to give you the background behind this, because a lot of times it is very tempting to teach some of this and just, here's the formula, here's the formula, here's the formula, which works just fine. But I feel like if you know where it's coming from or how we get it, you get a better understanding of how the thing works. And at this point here, we just have to type it in. So we can say second cosine inverse fraction, 7.9 squared plus 14 squared minus 11 squared over 2 times 7.9 times 14. And that's it. So we get 51.595999702. But if we're going to the nearest tenth, 51.6. So angle A is 51.6 degrees. Any questions on this so far? So we found one of the sides and one of the angles. We're just missing an angle, yes? Now, there's two ways we can go about it. One is just grabbing the formula that's now looking for angle C instead of A. Because what we can also do is add them together and subtract from 180. Because any three angles in a triangle add together to be 180. So 34 plus 51.6 . 85.6. Four gives us 6. 4 is, that makes C 94 point. So for our final answer, the measure of angle A was 51.6 degrees. The measure of angle C was 94.4. We'll click on the decimal. 94.4. And side length B was 7.9. And that's it. Questions on this here? We need to see another example of one like this. Or do we feel comfortable with this here, given two sides and an angle? Yes? Okay. Because if we feel comfortable with that, we'll move on to the other type, which is side. So we're given all three sides. I don't need to find another side. I just need to find an angle. Do we want to find A, B, or C first? So we can do B and C because we'll need to find two. Now, B is going to be equal to cosine inverse of our A squared plus C squared minus B squared over 2AC. And angle C is going to be our cosine inverse of A squared plus B squared minus C squared over 2AB. And again, when I look at these, whichever angle I'm solving, inside the cosine inverse function will be the one we're subtracting, and it's the side that's not included on the bottom of the fraction. So for angle B would equal cosine inverse of A in this case is 12 squared plus over 2 times 12 times 20. And at this point here, we just need to type this into the calculator. Because if we type this in, it'll give us the answer. $12 and $20, yes. 12 squared plus 20 squared minus 27 squared over 2 times 12 times 20. So 112.6 what? So if we're going to the nearest tenth, it would be 7. Let me look. Yep. You added the 27 squared instead of subtracting it. Now C is going to be our cosine inverse of, so a squared is still 12 squared, plus b squared is going to be plus our 27 squared minus 20 squared. And the denominator is going to be 2 times 12 times 27. So if you want to go back and recall the top one and change it, essentially make the 27 now positive instead of negative, and make the 20 negative instead of positive, and replace the denominators 20 with 27. Any questions on how we found the measure of angles C and B? Any questions on any of this so far? Okay. Erase this here. Try again. Now we still need to find angle A. And we could do the exact same thing we did. Or we can add these two together and subtract from 180. So 112.7 and 43.1, 8,551. So the measure of angle A is 24.2 degrees. The measure of angle B is our 112.7 degrees. And the measure of angle C is our 43.1 degrees. And that's it. That's all we have to do. Any questions on these here? Okay. I have a feeling that y'all are good with these here. And that's it.